All right, so welcome everyone to your Thursday evening dose of astronomy. So excited to be here again. I'm Irene Pease with the Amateur Astronomers Association from New York City, and we're going to be taking a look at some moons this week. We use two different programs. We'll be using OpenSpace, which you can see in the background now, and you can download for free at openspaceproject.com. And also, we'll be using Stellarium. So we'll click over to that in just a little bit, and you'll be able to see that and download that for free if you would like to use it at stellarium.org. So we'll go ahead and just jump right in for our week here to Stellarium. So we're back. Here we are, Brooklyn. It's now, or not quite now. I guess I need to, whoops, how'd that get there? So weird. That's more now. We have the tree back over here, so when we look over towards the west, I would like to look over towards the west and say, what's going on over there? And normally there's this tree in the way, but I was like, hey, it's actually kind of not in the way. So things are kind of dipping down towards the south. We're getting closer to the equinox, and then we'll get into winter. So the sun will be setting, the ecliptic, and all the planets when they set. Well, if they're setting near the sun, they'll be setting further and further towards the south. So let's go ahead and flip that forward to apparently now. So we have some excitement as usual. This is we're doing a little bit of Moon-topia, and I decided to call this episode 4 because why start at the beginning? We're just going to jump around because it's a big crazy universe out there, so why not? But this might be like a monthly thing because there's so many really cool moons in the solar system. And so I just want to be able to explore whatever moons we feel like for the week. So for this week, we're doing Moon-topia now because the moon, our single fabulous natural satellite, is going to be close to Jupiter and Saturn in our sky this week. So this is tonight and tomorrow, even closer. So I'm calling this Moon-topia because we have our moon, and then if you zoom in, look with a telescope or binoculars, you'll also be able to see. And of course, our moon is magnified here a little bit so you can see the phase better. If you zoom into Jupiter, you have the Galilean moons, those 4 bright ones. And if you look at Saturn with a telescope, I don't know if they're really visible with binoculars, but with a telescope, sometimes you can see a few. Iapetus will be visiting Titan, the larger one. Really great atmosphere. We have cool pictures of that. So that's where we're kind of headed this week. So I didn't really have a huge challenge. I feel like it's kind of a repeat challenge, but that's okay. Our challenge for this week is one, look for some moons. And tomorrow is your daytime challenge of trying to find Jupiter during the day. So as I may have mentioned in the past, if we kind of go back in time a little bit to daytime, Jupiter is relatively bright. It's one of the brighter objects in our sky after the sun, moon, and Venus. And it is sometimes visible during the day. It's easiest to find if you know where to look, obviously. And so I like to use the moon as a marker. So every month, the moon going through its phases, makes a full circle around our sky. And we're able to see it kind of pass a little bit near Jupiter. And tomorrow is a pretty close pass for daytime. So sometimes it's several degrees off. And again, keep in mind this moon is magnified. But if you go outside tomorrow, kind of early on, while the moon is still up, you can see, or actually not early on, it's going to be later in the afternoon, early evening, with the moon up, Jupiter will be up. And you'll have a chance to kind of use the moon as a marker to kind of point you towards where Jupiter might be in the sky. And it's not going to be like huge and glorious. Obviously, it's a tiny little dot, but it is relatively bright. So that's a fun challenge, a little daytime challenge if you're not clouded out tomorrow to look for that. So a little bit of a challenge for the day. I didn't really have nighttime challenges for this week. There's a fun thing happening next week with the moon and Mars, and I'll get into that more next week. But for this week, just enjoy the moon kind of passing by the planets. And I say this every week, but if you haven't, check out the planets because, they're pretty awesome. So that's our stellarium. So stellarium, do a lot more with stellarium. We did a lot of stellarium last week. But for now, I think we'll pop on over to some open space. So open space, again, you can find this. This is freeware that you can download from openspaceproject.com. And it's freeware. It's open source, so you can download it. It helps to have like a pretty solid graphics card to kind of see what you're doing with that. But you basically load in all this real data. So all of the stars that we see in the background, those would really be there. This is kind of like if we were out in space yesterday. I have this set for yesterday. I was going to comment and say, like, if it's cloudy tomorrow, if you're in the path of the tropical storm that's coming along, we have, this is kind of the hurricane that smashed into the Gulf Coast. So this is from yesterday before it smashed in, but you can actually see it in there. So these are kind of daily images of the Earth taken from space. So actual images from the weather systems that we can go back different days. And we did that a week or two ago when we looked at several storms, not just on Earth, but storms in other parts of the solar system. So pretty tremendous power and energy in the hurricanes here on Earth. But if you want to learn more about storms on other planets, you can check out the other storms brewing from a few weeks back. But for this week, Moon-topia. So I'm going to kind of pass by our moon, but I wanted to take a look at just a couple of other moons in the solar system, kind of moving outward. So we do have our fabulous moon. We just call it the moon. There it is. It's a little orbit. So if you were out in space, again, this is real data. You wouldn't see those lines. So those are just lines that are kind of marking where the orbits of the planets are. So you can see the orbit of Earth. If we move out a little further, you can see all the inner planets. So we have the Sun, and we have the orbit of Mercury, Venus, Earth, and Mars. And for our first stop, we're going to head towards Mars. So Mars has 2 moons. They're very small and potatoey, but Mercury and Venus don't really have any. So Earth is the first planet out from the Sun that has this lovely natural satellite. But the moons of the solar system, there's so many. There's a few hundred, and they come in close to a few hundred, I guess. They come in all shapes and sizes and colors and flavors and things. Just incredible diversity. The moons of Mars are almost like small captured asteroids. So here we are coming up on Mars. You can see the orbits of its 2 moons. And we're moving in towards, I guess, the closer one, Phobos. And we don't have the high-res images. I didn't load high-res images into here for Phobos, but I'll show you what we do have. It still kind of paints a picture. All right. Ooh, look at that. There's a blob. All right. So Phobos isn't quite that smooth, but it is kind of that potatoey shape, right? It's not spherical. So the moons of Mars, like I said, they're more like captured asteroids. They're very, very small, and I have a pretty picture for you. So, there's a pretty picture. Pretty picture of Phobos. They're not massive enough to have pulled themselves into a more spherical shape. So that's kind of the hallmark of massive objects in the solar system. If you have enough mass, then everything gets pulled in towards the center, and so it assumes a somewhat spherical shape. Usually these things are slightly pudgier at their equators because they're spinning, um, but if they're not even able to pull themselves into a spherical shape, if they're more oblate, if they're kind of like ovally or like an Easter egg, as Tom's saying, then yeah, they don't have that much mass. So you need, I don't remember that, I don't have an actual number, but more mass than Phobos and just a little bit less mass than the next moon that we'll be looking at. So I keep forgetting. I can't actually rotate around this. This is a beautiful image out of NASA JPL, Caltech, and the University of Arizona happens to be my alma mater. So shout out U of A, bear down. But you can see this kind of huge impact. I mean, the whole thing is covered with impacts. So no atmosphere, just like our moon. So it's not really protected. It doesn't have that teeny tiny thin layer of any kind of air or gas that would burn up any little micrometeoroids that are coming its way. So everything that comes along smashes into it and leaves a crater, some big, some small, some pretty big. So this is a pretty big crater on Phobos. That's a Stickney crater. It's named after some astronomer's wife. But there's this funny thing in the solar system. There's rules. We have rules in astronomy. And one of the rules is Pluto's not a planet. I'm just going to leave that there because it makes a lot of people mad. So there. One of the rules is about naming things around different planets or naming features on different objects, different worlds. And so for each of the moons, there's like the features on these different worlds, these moons, are named after people or places or characters or whatever in specific stories. So the Phobos story is from Gulliver's Travels. So if you're a fan of Gulliver's Travels and you view like a list of like all the geological features or phobological or whatever on Phobos, you might recognize a lot of those. So that's kind of all I had to say about Phobos. It's kind of neat. It's not going to be there forever because it's not like a super stable orbit. Again, just a captured asteroid, probably eventually going to crash into Mars. But you don't have to worry about that anytime soon. If you're planning on moving to Mars, you'll be fine. You can see, Phobos floating along in the sky. But giant crater on it. A lot of the bodies in our solar system, whether they have an atmosphere or not, the atmospheres you get like a lot more erosion, but a lot of them have like kind of a big like smash, big record of a smash in the past. So on Mercury you have Calorus Basin, and on Mars it's Hellas. And the other two moons that we look at are also going to have big craters on them because I don't know if anyone got like the whole Death Star theme. Anyone? No, okay. So Phobos doesn't look anything like the Death Star. But the next moon that we're going to go to is sometimes known as the Death Star moon. So we're going to go out, way out here. We're going to skip over Jupiter, and we're going to take a look at a couple of moons of Saturn. So inner planets, and then we have a whole bunch of asteroids between the orbits of Mars and Jupiter, and then out past Jupiter we have Saturn. So all the outer planets have quite a few moons. Saturn actually has the most known moons of all the planets at this time. We keep finding more and more. So currently the count has Saturn at 82 and Jupiter at 79. So just in the last year or so, just mining some of the data from the Cassini-Huygens mission, they found 5 more of these Saturnian moons. So these are just some of the brightest ones. It has obviously a lot more than this. So, but just showing the orbits of some of the larger moons. And we're actually going to start off pretty close into Saturn. So of the largest moons, it's 5 or so largest moons, we're going to start with the one that's closest to Saturn. So little Mimas, also known as the Death Star moon. I won't even try to do the music, but I mean, y'all can see what I'm talking about. It's clearly, just clearly, just saying. All right. So this is Mimas, aka Death Star Moon. So this is mostly spherical. All right. So I'll go ahead and adjust the shading on here so we can see it in a little bit more detail. So we do have like these. Whoops. We do have these nice high-res images from the Cassini-Huygens mission. Again, they circled around the Saturnian system for quite a while and got really great detailed maps of a lot of the moons and discovered several moons I mentioned. So we have this beautiful map of Mimas. And one of the things that we noted about it is, one, it has that really cool feature. So that's the Death Star crater. That's Herschel Crater on Mimas. Clearly, its largest crater. So that would be again like Hellas or Chloris on Mars or Mercury, respectively. But the thing about Mimas is this is about as small as a world can be and still pull itself mostly into a sphere. So it seems fairly stable. Again, Phobos wasn't quite massive enough, so it was more potato-y and more oblong. Mimas seems to have just about enough mass. So Mimas is it's just under 400 kilometers across. So it's not very big. I think I read it has like about the same area as Spain. So if you know Spain, I don't know, I'm not that familiar with Spain to be able to kind of compare land areas. But again, no atmosphere, so it has lots of craters. And the the story for Mimas, that was where was that one? Those are Arthurian legends, except for the Herschel Crater. So they made the exception for Herschel Crater, but the rest of the features on Mimas here are named after Arthurian like characters and places and things. And don't ask me to list them because I don't know. I didn't read. I'm not a huge reader. But the other kind of interesting thing, a couple interesting things about Mimas. Again, we noticed that it's relatively close to Saturn, so it's the closest of the larger moons to Saturn. And I mentioned that it does have enough mass that it's pulled itself mostly into a sphere, but it still has like a weird kind of wobble. Our moon wobbles a little bit, and Mimas, we've been able to explain it with our moon, but with Mimas's wobble, we're not really sure exactly why that's happening. So there may be some weird kind of uneven mass distribution, maybe resulted from the impact that caused Herschel Crater. So that's kind of still a mystery with Mimas. Another cool thing that Mimas does is it has an effect on the ring system because it is so close to Saturn. So all of the giant planets, the gas giants, Jupiter and Saturn, and the ice giants, Uranus and Neptune, have a ring system. Just Saturn's are by far the most extensive, the most noticeable, the brightest. So if we look at this, oh gosh, that's gorgeous. Gorgeous ring system. Let me just bring this around a little bit. Mimas actually helps control some of the gaps in the rings. So we label the rings, so there's like I think we go from outer to inner. So the inner part, these darker rings in here, that's the C ring. And then this bit in here is the B ring. And then we have the largest gap in the ring system. So that larger gap in there, that's the Cassini Division. So the same person that the Cassini-Huygens mission was named after. And then way out here, we have the C ring, and there's another kind of big gap that some amateur astronomers, if you're looking at Saturn and its rings with your telescope, the Cassini Division is a fun thing to look for as far as detail in the rings. And then sometimes you can even see the Echi Division. So very, very small division out here in the C ring. So as far as the B ring, so when you kind of notice the ring in here, the kind of medium shaded ring, because of the gravitational pull of Mimas and the gravitational pull of Saturn, we get certain places where it's just not very stable for the ring particles to be orbiting around Saturn. I'm not sure exactly how related. I think there's something somewhat similar, like in the asteroid belt. I remember having to write this massive program back in the day for undergrad, where we had to model the Kirkwood gaps, which are these gaps in the main belt of the asteroid. And so it was like an n-body simulation. You had the three gravitational masses. You had Jupiter and Mars and the Sun, and based on the gravitational pull of those things, you dump a bunch of little masses in between Mars and Jupiter. And it turns out that with the periods of the planets, there are just certain distances from the sun that are not stable, and so you get these gaps. So something kind of similar is happening with MIMOS here. So the outer part of the B ring, it's kind of like shepherding. There are shepherd moons that are within the ring system, but I'm going to say it's semi-shepherding because the outer part of the B ring, those particles are in a 2-to-1 resonance with MIMOS. So every time MIMOS goes around Saturn once, they go around Saturn twice. And then the inner part is in a 3-to-1 resonance. So you have these particles that are kind of between resonances, and then to jump beyond that, it's like just not as stable. So they kind of stay in that ring a little bit. So that's why we say MIMOS kind of helps form that Cassini division, that big gap in the ring. So the next time, for all you observers out there, you're looking at the Cassini division, think, oh yeah, Death Star, totally blasted its way through there. Just kidding, that's not at all what happened, but it's a better story. So Faisal's asking, isn't the Cassini division just about the width of the United States? Great question. I have no idea. I just know it's the biggest one. So I'll go with sure. Yeah, the ring system, they're super, super thin compared to the width. It's like paper thin compared to how big it actually is, how wide it is. So one more super fun moon. And again, it'll still have a Death Starry feature because that's kind of that's the whole episode 4 theme. So one more moon, more of the outer moon of Saturn, unless there's requests, but I didn't study up on all the moons in the solar system. Still learning. That's how we learn, kids. Iapetus. So Iapetus is kind of interesting. It's got a lot of personality. So here we came right up on it has a lot of like big craters, but this is the largest one that we're seeing here. So that's Targus Crater. So all of these features now, they're characters or references from a French epic poem, The Song of Roland. I'm not even going to try and say it in French. I asked one of my friends to pronounce it for me earlier this evening, and I was like, yeah, no, that's not going to happen. We're just going to go with Song of Roland. That's my American accent for that one. You're welcome. So Iapetus, yeah, really interesting, kind of can't help but noticing the coloring. So huge crater, so it doesn't look as Death Starry as MIMOS. Like MIMOS totally wins the Death Star contest. Iapetus, let me see if I need to change the shading on here so we can see more detail on it. So we'll just do our shading here. Woo! And again, we have like the more detailed maps, pretty complete maps of Iapetus from Cassini-Huygens. So you can see there's a big crater here, there's a big crater here, and there's a big crater. Whoa, there's all these big craters. So what a fun little moon. Wow, what a super fun world there. But yeah, the shading here, which is kind of interesting, kind of a mystery. But there's some theories about how that works. So basically the dark side, that's the leading edge. And then the light side, so it's kind of like wrapped around, it was compared to like a tennis ball, the way it's kind of wrapped around. So the leading edge is basically this darker region. That's the Cassini Regio. and then the white part, that's the lagging edge, right? So this is on the far side as Iapetus goes hurling around Saturn, and kind of lost track of which way is like kind of north or south here. But one part, they have different names for like the two different hemispheres. So the northern part and the lower part are the Roncevaux and Sargasso terras on Iapetus, but very, very different. So why is it so different on the leading and lagging edges? So I think it was Cassini actually thought he noticed this when he was back in the day trying to see Saturn's moons through his telescope. And he noticed he could see Iapetus when it was on one side of Saturn, but not when it was on the other side of Saturn. So he could see it when it was moving away from him, so the lagging edge, that was the white part, but he couldn't see it when it was coming towards him as it went around Saturn. That was the leading edge. So Saturn, most of Saturn's large moons and Jupiter's large moons, just like our moon, they're tidally locked. So the same side is always facing Saturn, and the same side is always like plowing through space. So this is the side that goes plowing through space. So we think that maybe there had to be some kind of trigger event to set this off, and the trigger event may have been maybe some meteoritic kind of dust from an even further out moon, possibly Phoebe. So they're maybe blaming Phoebe, which is smaller and further out. And so if some of that matter was like infalling towards Saturn and then got plowed into by Iapetus, so that it got a little bit darker on that one side, that would set off kind of like this runaway effect. So what they think is happening is because the side is darker, it's absorbing energy. It doesn't reflect light, so it absorbs it. So that gets warmer, and so the ices here melt, and then those gases, or they won't even really melt. Sorry, they're not going to go from solid to liquid because there's not enough pressure out there. So they actually sublimate out where there's not really an atmosphere. But those gas particles then, when they go from a solid to a gas, they could still recollect on the far side. So you have this lighter, more icy lagging side, and then that just gets more reflective, so it stays cooler. So this side is less likely to sublimate and lose its ice, and you get kind of like this feedback. So as Iapetus is going around Saturn and the two different sides get exposed, the dark side, there's going to be more sublimation, so it's going to lose ice, and then again those particles could collect and solidify on the lagging side, but then that lagging side never gets as hot as the leading side, even when it's directly exposed to the sun, the same amount of sunlight as the leading side, because it's more reflective. So it's like if you're sitting in a white car versus sitting in a black car in the Tucson sun, waiting for your roommate to pick her up from the University of Arizona, and it's just really hot because there's no air conditioning, and then she doesn't want to roll down the windows. But anyway, we won't get into that. That's no one you know. So that's Iapetus. Kind of a interesting little moon there. Maybe not quite so little. It is one of like kind of the bigger moons. So this is one that you can sometimes see in a telescope, that one, and Titan. Mimas is a little bit harder to see because it's a lot smaller. Again, it's kind of more on the edge of just barely being massive enough to pull itself into something spherical. So that's just a couple moons. Little bit of moons for you. So if people like the Moon-topia, maybe we can do another Moon-topia next month. Feel free to request moons. I'm always happy to learn about more moons in the solar system, because there's a lot of them. Like we said, we have, I think I'm trying to do math in my head, which never is a good idea, close to 200 moons in the solar system. We don't have super awesome images of all of them, but we're getting there. So, so thanks so much for joining me. Again, I'm Irene Pease with the Amateur Astronomers Association in New York City. You can find out more about the association and the fun things we do at aaa.org. And just a quick plug, we do have 3 classes coming up this fall that are all online. They're open to our members, so very exciting. I'm teaching Astronomy 101. We have astronomy, like multi-wavelength telescopes and light, where we're going to be looking at the universe in different wavelengths because there's all kinds of light that our eyes don't see. So that's pretty exciting. And we also will have a urban astrophotography class. So if you're wondering about taking really cool pictures of the night sky, even from really bright, light polluted New York City, we know some people who know how to do that. So check out our website, follow us on all the social media things at aaa.org. And if you're interested in the visuals that you saw tonight, again, you can check those out and download them and use them yourself. OpenSpace, which we have in the background right now, at openspaceproject.com, and Stellarium, which we saw earlier, which you can find at stellarium.org. Thanks so much for joining us for your Thursday evening dose of astronomy. Have a good night. Be safe out there.